So this is an overview of panelling of the boat cover, defined by a series of frame curves using mPanel production. There's been a certain amount of preparation of the data here, in that the digital measuring equipment will have contained some roughnesses and some missing parts in the traces of the edges, and we would use some of the smoothing tools to obtain a smooth shape which goes smoothly through the measured points, and we would also use some of the other tools to resolve problems where it's difficult to measure tight into a corner or on the back face of a tube. We'll show adding some meshes. Basically we try to get the structure to where we have 4 edges available for the mesh, and we'll then add in a mesh, choosing the number of points in the 2 directions to get a mesh which isn't horribly dense, but has got enough density, enough threads in the mesh to describe the shape well. We'll select the bottom edge of one of the meshes, the right, the top, and the left, and that adds in a mesh there. I'll add in one more and then just do the rest of them off camera to save time. Here we'll add a mesh in on this edge here, curve, as the bottom. This is the right. We will skip the top edge by entering, and here's the left edge, and in that way we would build up the meshes over the boat. And here's the model where I've completed the meshing, and just for clarity and understanding stuff, I've coloured the meshes here. And what we would now do is we would convert each of those meshes into a panel. So I'll start off by just making a copy of that whole model this way. In my drawing I have kind of like a progress of as I've gone along, and then we would just select the meshes one by one and convert those into a panel. I'll delete the old mesh there, and there's the panel for that particular place. We'll produce the panel for the side piece there, and we'll continue on and do that paneling all the way through until all of the panels are produced. I'm moving these off to the side to make it clear what I'm doing. Normally I'll just panel all of them in place. So here's the full set of panels for that cover. Those panels would then be, often they would be either shrunk slightly to give a really tight fit, or they would be enlarged slightly to give a slightly loose fit. And on a boat cover, often they would be enlarged slightly. We specify the shrink setting, so you can see we have a shrink of -0.5% and -0.5% there, which is of course an enlargement. So we would shrink those panels. Again, I'll delete the old. All those panels are now just a little bit bigger. And we would go in and add a seam allowance to these panels. Now, on some panels you may want a different seam allowance. All the ones down at the bottom edge, for instance, you may want a larger seam, maybe to hold a rope or a bungee which goes around the bottom there. But for now I'll just say that that we'll keep the same seam on all sides. We can specify different seams. And of course we want automatic match marks, that is automatic marks to line up one panel against another, and we can produce those, we can seam those panels like so. So those have all been seamed. Again, delete the old, and if I zoom in on this you can see the marks on this panel that are going to sew up against the same mark on this panel, and that mark is going to be that mark all the way through. copy of those. We'll have a quick look at different ways of naming these panels. The large numbers in the middle are our internal, our sort of reference numbers, and those numbers will automatically be taken off the panels when they're sent to the cutter. And we can either have that number written into the seam, and that's done during the stamp settings where we add a panel number into the seam, or the way that I'm going to show it to you instead is to create assembly marks which will tell the operator which panel sews to which panel exactly. Adding assembly marks is a two-stage process. We first draw the assembly lines between the panels that show how the panels are connected together, and then taking that assembly lines drawing, we draw in the assembly marks. Delete the old, and what we'll find now is that on each edge there will be an instruction to match 151 to 152. On this edge, match 151 to 152, so those two join together. Here we've got match 148 to 151, 148 to 151. So you have precise assembly instructions for the panels in the seams. Of course, if you want to, you can also have the panel numbers printed off, but often the match instructions, the assembly instructions in the seams are all that are needed. We'd then look at the stages that we need to get the panels to the plotter, and an optional stage is doing some nesting. Nesting makes the maximum use of the fabric and can save money in the long run. Nesting is an optional license with mPanel, so it's an additional license that you can buy from your distributor. The nesting is a two-stage process. The first stage is that we arrange the panels essentially horizontally, and we then specify in the nesting that they can twist a certain amount from that horizontal position. And the nesting is quite straightforward. We just pick up the panels and the roll. This is indicating the fabric, the fabric roll which we are going to nest into, and then we run the nesting process. And so here we have the panels fitted into the tightest space on the roll. You can see that some of the panels have rotated quite a lot. You may not want to see that. Of course, it will affect the look of the fabric as you change that warp angle. But we can just use a smaller warp angle limit to restrict that. And then the final stage is that we would output the panels. And outputting the panels consists of making the changes to the panels which are necessary to make it work well on a cutter. And different cutters have different requirements. Generally, you set up a layer specification and a color specification for the outputs. We usually output directly to the DXF, to where the panels would now just go to a DXF file for sending straight to the cutter. But to show it on screen here, I'll draw these out into the drawing. Another important thing is that many cutters are very slow at drawing text, and so we can convert that text into a vector font which the plotters and cutters can draw much more quickly. So we'll just run that through that final output stage. Delete the old. You can see that all of the large panel identification numbers have gone. The cut line in this case is defined by cyan, the plot lines are defined in blue, and the information, the text information, has been drawn out in a simple vector font. And that completes the design process using mPanel from the frame structure through to output panels.